This video is on alpha, beta, and gamma decay. Question 1. Define random and spontaneous. Random means no pattern. Spontaneous means unplanned. Radioactive decay is both random and spontaneous. That's question number 2. Question number 3. Define alpha particle. What is it made of and what is its charge? An alpha particle, alpha is the nucleus of a helium atom, which has 2 neutrons, 2 protons, and 0 electrons. It has a charge of +2. So a common mistake is saying an alpha particle is a helium atom. No, it's the helium nucleus. Question 4. What is the difference between an alpha particle and a helium atom? A neutral helium atom has 2 electrons. An alpha particle has 0 electrons. An alpha particle leaves the nucleus of an unstable atom during alpha decay. Question 5. Give 2 examples of alpha decay. So let me just pick this element here from the periodic table. YB. It's called ytterbium. 70 protons, and it has a mass of 173. So let me just subtract a few neutrons to make it unstable. So I made it go from 173 protons plus neutrons to 150 protons plus neutrons. So now it's going to undergo alpha decay. So the 70, and I'm highlighting it here, the 70 protons become 68 protons. And the 150 protons plus neutrons becomes 146 protons plus neutrons. And then now I go from YB to ER, erbium. Now it's going to undergo alpha decay again. So it's going to go from erbium to DY, dysprosium. So I'm going to go from 68 protons to 66 protons. And I'm going to go from 146 protons plus neutrons to 142 protons plus neutrons. Because after every alpha decay, I lose 2 protons and 2 neutrons. So what I'm highlighting here is 2 alpha decays. First one I go from ytterbium to erbium, and the next one I go from erbium to dysprosium. Okay. Here's another example. Sn is tin. Tin is a stable element. It has usually 118 protons plus neutrons. Let me take away a few neutrons to make it unstable. So now I have 100 neutrons plus protons. So when it undergoes alpha decay, I'm going to lose 2 protons. So the 50 becomes 48. And then the 100 protons plus neutrons becomes 96 protons plus neutrons. And then cadmium is also unstable, so it's going to undergo alpha decay. So it's going to go from cadmium to palladium. So what I'm highlighting here in gray is 2 alpha decays. Question 6. Define neutrino. What is it made of? Charge, mass. The neutrino, this is a Greek letter, I'll just call it V, is an elementary particle with no charge and almost no mass. That means you cannot break it down into something smaller. Neutrinos are the most abundant particles in the universe. A neutrino leaves the nucleus of an unstable atom during beta plus decay. So, according to Wikipedia, the mass of a neutrino is less than 2.14 times 10 to the minus 37 kilograms. So they are very difficult to detect. Okay. Compare this to the mass of an electron, which is 10 to the minus 31 kilograms. So a neutrino has about 1 million times less mass than an electron. So if you think an electron is light, think about how light a neutrino is. Okay. Define antineutrino. An antineutrino is the antiparticle of the neutrino. The antineutrino is an elementary particle with no charge and almost no mass. The antineutrino is not as abundant as the neutrino. There are fewer antiparticles in the universe than particles. An antineutrino leaves the nucleus of an unstable atom during beta minus decay. Okay. So, once again, an antineutrino is incredibly light, according to Wikipedia. Question 8, define positron. What is it made of? Charge mass. A positron is the antiparticle of the electron. A positron has all the same properties of the electron, except it has an opposite charge and some other opposite quantum numbers, which we don't need to learn yet. Question 9, define beta plus particle. What is it made of? Charge mass. A beta plus particle is a positron, the antiparticle of the electron, which leaves a nucleus during beta plus decay. Question 10, what happens to a proton in a decaying nucleus during beta plus decay? A proton decays into a neutron, a beta plus particle, and a neutrino. The neutron stays in the nucleus of the atom. The beta plus particle and neutron both leave the atom. So memorize this. A proton becomes a neutron, beta plus particle, and a neutrino. So question 11, give 2 examples of beta plus decay. So carbon, which has 6 protons, becomes boron, which now has 5 protons. And a beta plus particle leaves the nucleus, and also a neutrino leaves the nucleus. What is a beta plus particle? Well, we just learned it here. It's a positron. It's an antiparticle of the electron. So you notice this 10 on the bottom is the same as this 10 on the bottom, because the number of protons plus neutrons in carbon, it's going to be equal to the same number of protons plus neutrons in boron. Except we have 1 less proton and 1 more neutron. Here's another example. We have 59 protons plus neutrons in copper, and then we have 59 protons plus neutrons in nickel. Copper had 29 protons. Nickel has 28 protons. Question 12, define beta minus particle. What is it made of? Charge mass. This is a beta minus particle. Question 13, what is the difference between a beta minus particle and an electron? It's this over here. Question 14, what happens to a neutron in a decaying nucleus during beta minus decay? Memorize this. In beta minus decay, a neutron becomes a proton, a beta minus particle, and an antineutrino. The proton stays in the nucleus. The beta minus particle and antineutrino leave the atom. Question 15, give 2 examples of beta minus decay. So understand these 2 examples. So in the first example, we have 6 protons in carbon, then we get 7 protons in nitrogen. Carbon had 8 neutrons, nitrogen has 7 neutrons. Okay. Like I said, understand these 2 examples. Question 16, why was the neutrino postulated? Why did people assume that another elementary particle exists? Beta minus and beta positive decay did not conserve energy and momentum in the following reactions. Okay, so two elementary particles were postulated, their reactions were modified to conserve energy and momentum. Once again, memorize these decays. What is the charge and mass of an electron? What is the charge and mass of a neutrino? So this problem here, 17, is trying to show you that it's difficult to detect an electron. It's even more difficult to detect a neutrino because it has no charge. So it doesn't really react to anything. Question 18, define gamma ray. What is it made of? Charge, mass. A gamma ray is a high energy electromagnetic wave. It has no charge and no mass. Question 19, why is it not correct to use the term gamma particle? Gamma rays have no mass. Since they have no mass, they are not particles. It's a simple mistake people make. Question 20, what is happening to an atom during gamma decay? In gamma decay, the nucleus of the atom is going from unstable high energy to stable low energy. In gamma decay, the nucleus releases energy in the form of a high energy electromagnetic wave, a gamma ray. Question 21 gives you two examples of gamma decay. Question 22 and question 23, define ionization. Which particles have the most ionizing ability? Okay, so alpha particles have the most ionizing ability because they're the most charged. Gamma rays have the least ionizing ability because they're not charged. Question 24, define to penetrate. Question 25, define penetrating power. Which object can we use to stop an alpha particle, a beta particle, a gamma ray? To stop an alpha particle, we could just use thin tissue paper. To stop a beta particle, we could use thin aluminum foil, and a gamma ray, we need a few centimeters of lead.